Guys, welcome to Pen Dentistry. Hope you are doing good. I am Dr. Aishwarya with you for easy learning and better understanding. If you haven't subscribed to my channel yet, please go and subscribe to my channel and learn the dentistry in an easy manner. Today our topic is on theories of orthodontic tooth movement. Why we are studying these theories? Because in orthodontic, tooth movement is very necessary. Tooth movement is necessary while application of the force the movement of the tooth takes place, and why that movement takes place because of the crystals or bone or resorption or making. These things happen, and now we are going to study all of the theories and what happens in these theories and what they have said about the tooth movement and how the tooth movement is occurring, that we are going to see. So that's why we are studying theories of orthodontic tooth movement. First one is mechanochemical hypothesis. Mechanochemical hypothesis was given by Justus and Luft in 1970. As you can see, Justus and Luft has given in 1970 the mechanochemical hypothesis. As per the theory, application of physical stress. When you are going to apply the physical stress, if this is the body, if this is the bone of the tooth, if you are going to apply the physical stress, okay, on the bone, that changes the solubility of the hydroxyapatite crystal. If the bone is containing the hydroxyapatite crystal, at that time it will going to change in it will going to change the solubility of the hydroxyapatite crystals. The force change in the hydroxyapatite crystal leads to remodeling of the bone. Okay, if you are applying a force, the solubility will be taking place here, and it will going to remodel. The remodeling of the bone takes place. So this theory is not accepted because any proof was not there for the solubility. So mechanochemical hypothesis is not accepted. Now we are coming on bioelectrical theory. In bioelectrical theory, when the force is applied on the alveolar bone flex and bend, what happens? When the force apply on alveolar bone, the flex and the bend takes place. The bending takes place due to the application of the force, which leads to the alteration in the bone metabolism. The bone metabolism will going to be changed, okay, inside the bone when you are going to apply the force. So we are going to study in bioelectrical theory the three theories: piezoelectric theory, streaming potential, and bioelectric potential. So in what I have told you, in bioelectrical theory, the force is applied and the metabolism of the bone is changing due to the flex and bend. So this is bioelectrical theory. We are going to take these theories in detailed manner. So let's get started. And the last one is pressure tension theory. Due to the pressure, tension is created. The name says that the pressure tension theory, it is also known as blood flow theory, and it is also said that classic theory. The three names are there of pressure tension theory: pressure tension, blood flow, and classic theory. Let's see every theory in detail and let's get started what they have said in every theory they have explained us. Piezoelectricity theory. Piezoelectricity theory is given by the Fukuda and Yasuda in 1957. What they have said that first I will be telling you what is piezoelectric. Piezoelectric is electric signals which is responsible for the tooth movement, and this is observed in mainly crystalline material. When the crystals are present in the material, at that time this piezoelectricity theory occur, and This phenomena is observed mainly in the deformities. That means crystalline material deformities. When there is a crystalline material and there is a deformities, if this is the object or the bone and there is a crystal material which is present and somewhere it is not present and somewhere it is present and there is a defect, that means the space as well as vacuum is present. As you might have studied in the chapter of matters in your 12th standard, the crystalline material. So if there is a deformity present, at that time the electric current will flow. So when the electric current flow from one place to another, from one direction to the another direction, that will cause the piezoelectric current. Flow of electron is generated in the body, where at the bone place at the collagen and collagen hydroxyapatite crystals. Bone, in the region of the bone, in the region of the collagen and in the region of the collagen hydroxyapatite interface, the piezoelectric current occur. This piezoelectricity possesses two features. One is the quick decay rate and the another one is reverse piezoelectricity. When the force is applied and piezoelectric signal is generated, you are going to apply a force and the electric signal is generated, which immediately becomes zero, which will going to become a zero immediately even after there is a continuous supply of the force. If this is the matter and you are applying a force, then the electric current becomes zero even after you are applying a force at that place. So this property is known as quick decay rate. Reverse piezoelectric is that when a force is applied and current flow from one direction to the another direction. Current is flowing from one direction to the another direction. And when the force is released, the current is coming back. That means the electrons are coming back in the opposite direction. This is known as reverse piezoelectricity. Piezoelectricity is a rhythmic and constant interplay of electric signals. When the force is applied, it will change, the changes will occur, the electricity, the electron will pass from one direction to the other direction. This will causes the electricity, this positive and negative charge will going to be occur here. Okay, this is rhythmic and constant. This tells about the homeostasis of this skeleton. This piezoelectricity, this says that whether the homeostasis is present in the skeleton or not. If the piezoelectricity is absent, bone mineral get lost. The loss of the bone mineral will going to take place if the piezoelectricity is not present, and this will cause the skeletal atrophy of the body. Okay, the role in piezoelectricity in orthodontic tooth movement is still in doubt. At the skeletal region it has considered, but during the orthodontic tooth movement we have some doubt because in the piezoelectric theory, because sometime it is not applied here in the orthodontic tooth movement. So hope you have understood this piezoelectricity. When the force is applied, the crystal material, the bone, the collagen or the hydroxyapatite crystal, they are going to generate electricity. This electricity will pass from one direction to the another direction. Okay, and this will transfer the electron. The electron will going to transfer. The electron deposition will be there. Okay, and this causes the piezoelectric series, causes the deposition as well as the bone. This also causes the change in the skeletal of the body. When the force is applied, the negative charge. Negative means here the resorption is taking place and here the deposition is taking place. This is not the Because of the piezoelectricity, the electricity will pass and this will leads to the deposition as well as the resorption of the bone. And this will cause the movement of the bone or the skeletal material. Streaming potential. Streaming potential, when there is a bone present, around this bone there is a fluid present. This fluid contains the ions and these ions help in generation of the electric field. Because of the electric field generation, bone bending takes place here. Because of the ions, the electric field is generated, and because of the electric field, the bone bending takes place. This small voltage of current occur at a small region. This is known as streaming potential. In orthodontics, this streaming potential is still under in doubt because exact theory was not present. So we are not considering this streaming potential. In orthodontics, tooth movement, bioelectric potential. Bioelectric potential is the when the orthodontic appliances is produced. When the appliances is produced and force is given at that region, and this leads to the physical distortion of the alveolar bone. The appliances causes the distortion of the alveolar bone. This causes the bending of the bone. What it causes? It causes the bending of the bone. Why the bending takes place? Because the force causes the stress of the bone. This stress causes the electric charge generation at that bone place. When you are going to apply a force, this causes the charge generation. At the concave region, the negative part will going to be generated, and the convex region, the positive part will be generated due to the electric current. These electric signal causes the cell permeability and cell membrane receptor activation. What it causes? The cell permeability as well as cell membrane receptor activation. This causes the bone remodeling. These charges will going to generate the remodeling of the bone. So this is the bioelectric potential. Deposition as well as the resorption will going to be takes place at the negative as well as the positive region. Hope you understood this video well. If you like the video, please subscribe and hit the bell icon for the latest upcoming videos. And please share this video to your friends and your batchmates for easy learning and better understanding. Keep watching Pen Dentistry.